Okay, so today's topic is going to be very, very interesting, and it is going to be very, very important topic generally, because mostly everywhere this is something that we use. Okay, you take your on-prem, you take other clouds, you take anything. This is one thing that is widely used. Okay, so let me quickly get to the topic. Our topic for today is going to be how does a request like life cycle of a request from client to your application. Like when you go ahead and write some website on your browser, that is your client, right? From there, how does the request reach a server is something that we will start today. Okay, in this course you'll understand that there is a component called load balancer, which is what we will be covering in AWS. So AWS related load balancers is something that we'll be understanding. So where does load balancer come into picture? We'll understand that, and then we'll create our own load balancers, and we'll see how the request is landing. Okay, so let's start. So generally when you go ahead and write something like google.com, okay, here, how does this request reaches a server or which is hosted by google.com, and how do you get this website here? Okay, when you type maybe mintra.com, this website goes to Mintra's server and tries to fetch this particular like details, and will show you this particular page. Okay, so how does this request actually go through is something that we'll be studying today, because it's very, very important. Okay, when you hit this is basically called as domain. Okay, so www.google.com, mintra.com, these are domains. Okay, world wide web, mintra.com. You can also have something like gov.in, government website gov.in, if you have seen. Okay, so this is like, this is email, but this is like india.gov.in. So this is Indian website. Now they are all domains. This is also .in is also a domain. Now what happens is, when now can you and me go ahead and like create a website called google.com now? No, because this domain is actually bought by Google. Okay, so you must have seen there are many news and all which happened recently, wherein one of the political party, they started a campaign but they forgot to buy a domain, which is why the other party bought it and all of that. Okay, now what is the significance of this is what I'm trying to tell you here. Okay, whenever you want to have like, whenever you want to have a website, example Parul.com, if I want to have, then I have to first go to a domain website wherein I can buy this domain. Okay, AWS, from AWS you can buy domains, GoDaddy you can buy domains, there is hostinger.com, there are other many .coms, bluehost.com, and you can buy it from Google, you can buy it from like Gcloud I'm talking about, and buy it from Azure. There are multiple places where you can buy this. Okay, now what happens is, when you go ahead and register this domain with them, this domain and domain name is registered for you, so nobody else in the entire world from even any other vendor will not be able to buy this domain. Okay, so example, google.com might have definitely bought it from their internal domain, from their domain like provider. If you go to the other domain provider and try to buy google.com, you cannot. Okay, there is a data sync that's happening in between. Example, India.gov.in. You cannot buy .gov.in now. Why you cannot buy? Because it is already bought by the government. If I talk to you about Myntra.com, why can't you buy Myntra.com? Because Myntra people have already bought this domain, so you cannot buy it anymore. So if you want, you can have Myntra123.com or something other.com, but you cannot buy this one. Okay. Now let's understand what happens there. If you go, once you go ahead and buy a domain, okay, it is something that is registered under your name now. Now, what happens is you then route this domain requests to your server. Then you create an entry there. That is when this particular ecosystem will come into picture. Now, what happens is when you go to google.com, okay, this particular website, like what your server does is it tries to go to a DNS server, that is domain name server, okay, DNS server, and fetches the details. Like when I say google.com, it says that you can go ahead and hit this particular URL, this URL, this URL. Now there can be multiple URLs that it is bind to, because if it is bind to only one IP, then if it is bind to one IP, then what can happen? If that IP goes off, google.com goes off, right? Correct? But we don't want that. So what happens is this same domain is, instead of like pointing to only one server, okay, or one IP, it is pointed to a load balancer, or in round robin fashion, like mounted to multiple IPs. So what happens is you hit a google.com, it will go to DNS server. DNS server will give you an IP back. You will then hit this IP and get google.com. Okay. Now, why don't we do this? Is because this is something that is done internally by our servers. Okay. So every server you have, every server that you buy already has these like IP, already has these settings, these DNS settings in your server. Okay. So it can actually go ahead and hit public DNS servers and fetch details from there. Am I making any sense? What happens? There is a domain. This is a domain which you have bought from. This is a domain that you have bought from, example, GoDaddy or Bluehost or AWS. There is a service called AWS Route 50. AWS hosted zones, or AWS Route 53, where you can get these, where you can buy these domains too. So you go ahead and you have bought this domain. You can't buy this domain, but example, let's take it as DevOpsCourse.com. DevOpsSRE.com is something that we have bought. Okay, when we buy it, it will give you it will allot that particular domain to you. Now what you'll have to do is, you will set this to point to an IP of your system, of your server. It can be a load balancer too. Okay, or it can be anything. Actually, it can be anything, any IP. Okay, but I'm expecting it to be a load balancer or an IP. It can be like other. There are other options too. So now when I pointed to that IP, what happens is whenever somebody tries to hit this, it will go to a DNS server. From that DNS server, it will fetch my IP and then display this. Now what is happening here? Whenever you make an entry in this domain server to say that this particular application should point to this particular IP, that is an A record or a C name, something like A record. You make a record. I'll tell you what an A record is. We will study these A records. Okay, you see A record. We will study these A records when we will be studying about Route 53. That's going to be the next topic. But I want you to understand this also. I can simultaneously cover these two topics, that is Route 53 and load balancers. But let's first only consider load balancer and then we'll add a Route 53. So what happens is, you have given a setting that this particular server, this particular, whenever you say this, it should point to this particular IP. Okay, that is an A record. Now what happens? Somebody hits this, it will go to a DNS server. How will it reach the DNS server? Whenever you make this entry in Bluehost, it gets synced to all the public DNS servers which are there in the entire world. Okay, once that syncing is done, then you will be able to make this resolution. This is called a resolution. Now what happens? This is very, very similar to name. Okay, whenever I say type google.com, it is easy for you, right? But when I say hit this particular IP, it will be difficult for you to remember this, right? Okay, so what happens is, instead of this, we came up with a concept called domains. Okay, why? Because this is a easily human readable format. Okay, so it can be easily read and this can be pointed to any IP which can then be resolved. Okay, so a person doesn't have to worry about this IP. All they have to worry about is remembering the domain. Okay, example, if I have to remember IP of Myntra.com, I'll not remember it. But if I want to remember this Myntra.com, it is easy for me. So now, if I want to call you, I'll call you by your name. Okay, example, if I want to call you by your Aadhaar card number, it will be difficult, right? It will be difficult. Or PAN number. It will be difficult for us to remember that, right? But it's easier for us to remember the name of an individual. Although your PAN card is again your unique identity, using which a person can be identified. But it's very difficult to remember all the numbers and everything for so many people. If you want to call them, you cannot call them like CJ212N. You won't remember, right? XYZ1212345N P something. You won't remember all of this, right? But you will remember their names, which is easy. So these are again human readable names. They have to be unique, because if it is given to a company, another company, if it buys the same domain, both of them can be pointing to other IPs. Now Myntra.com here is pointing to other IP, Myntra.com here is pointing to other IP. Then a person who is trying to hit the URL, your computer will be confused which one to point to. Okay, so that's why all of these DNS servers get completely synced. If you buy a domain, example, buy a domain called Parul123.com, it is going to be specifically for me. Okay, and then I can only point it to any place. Okay, that domain is under my control. Cool. Any confusions, guys?
No, sir.
Awesome. So let's go to the next understanding as to what is happening. Now, what we do is, again, second problem. If you have a domain and you're pointing it to an IP, okay, as I mentioned here, if you're pointing it to an IP, what is your major problem? What is a major problem? That if an IP goes down, if that machine goes down, that machine is like that IP can be of a machine, right? If that IP goes down for some reason, that component goes down for some reason, then your entire application is down, right? Which we don't want. Then what will we do? What will we do? We will point it, instead of pointing it to an IP, we'll either point it to a CNAME, a load balancer, or multiple IPs from which one of them your domain can fetch. Example, uh, this is my domain, and I've pointed it to a load balancer. A load balancer can have multiple IPs internally. Then, okay, then internally they can make the requests. Now, I have a domain. I can point it to cluster of IPs. Okay, whenever somebody tries to fetch, it can pick any one of these IPs now. That is also possible. Okay, so this is the major problem that happens. Now in AWS, this Route 53 option is basically that. Okay, here you can buy a domain. You can come here. There's an option to register a domain. Okay, and these Route 53 is how you route the request between multiple places. So before we go ahead to this particular topic, I want to help you understand that let's consider this part first. Okay, as soon as somebody tries to hit this particular URL, it will be either pointed to a load balancer or an IP address. What is a load balancer? As the name suggests, it balances the load. How does it balances the load? As soon as a request reaches to the load balancer has other applications, okay, which are registered to this load balancer. Now what happens is a request comes here. This load balancer can then look at the traffic. Okay, traffic is high on this one, route it to this one. Or this load balancer, if it is an application load balancer, it can understand what the request is coming in, and based on that, it can route the request. So load balancers is basically to route the request, okay, and distribute it on multiple servers. Example, I was talking to you about auto scaling and all of that, right? You remember? In auto scaling, we can have 2 servers, 3 servers, 4 servers, many servers, right? Now, if we have 10 servers, how will a request reach first server, 10th server, 9th server, or 4th server? How will it reach? There is going to be a load balancer above this. Okay, all of these 10 applications or 10 servers are registered on this load balancer. Now what happens is a request reaches to the load balancer. Load balancer will then balances the load and send it to any one of these servers, any one of these 10 servers, or 3 servers or 4 servers, depending upon the auto scaling part. Okay, so now that's what exactly is a simple load balancer. Okay, load balancer is simply to balance the load between multiple targets. Okay, now in AWS there is again a load balancing component. Okay, this is managed by AWS. Load balancers can be of different types. They can be reverse proxies, they can be like HA proxy, Nginx, others. Okay, there can be many, but in AWS they have a managed service for all of those load balancers, which is why I can see 3 types of load balancers here. Actually, 4. Uh, Keeping in mind that we have classic load balancer too. This one and this one is heavily used load balancers. Application load balancer and network load balancer. Okay. Application load balancer basically works on HTTP and HTTPS. That is application layer. You remember OSI model if you have heard of? If you haven't, Please read it out. OSI model. So basically, this is an OSI model wherein you have a traffic moving in this way. Example, if a request needs to go out of your system, okay, it will first be at application layer. It's not opening up. What is happening here? It will go to application layer, then presentation layer, then session layer, transport layer, network layer, data link, and physical. Physical as in the wire one. Then when it reaches to the app, like digital logs on your app, on your wire, will then reach the destination and will follow the reverse order, as in physical layer, data layer, network layer, transport layer, session, presentation, and then last is the application, which will be able to read the packet. This is how a packet in what do you say, in basic, in a simple machine flows. So I want you to read about it. If you have any questions, you can definitely come back and ask me questions on this. Okay, but I want you to read this particular topic. It's very, very important and interesting too. Okay. Now what happens is application load balancer works on application layer. Okay, that is this layer, this first layer, or last layer, depending upon where you are reading it. If you are at the source, then it is application. If you are at the destination, then it is the last layer. Okay, as I mentioned. So example, if I'm on application layer, then what happens is I can open the packet and see what is there in the packet, which means that I can see the headers. I can see the inner request flowing. Okay, it becomes a network packet, like an envelope. Okay, when envelope reaches the destination, that envelope can be like, there can be name, all of those things, okay, which is written outside that envelope, but there are things written inside that envelope too, right? So anything that you can open and see everything, when you can open and see everything and read what is there on that envelope, that is application layer. So in application layer, we can read headers, we can read path, we can read the domain. So all of these things we can read, which means at this layer we can make a lot of decisions because we have a lot of things to identify. Okay, so this is what is an application load balancer. In case of a network load balancer, a network load balancer basically works at this network layer. So you cannot fully open the packet. All you can see is the port on which the request is coming. Okay, if request is coming on this port, send it to this person. If request is coming on this port, send it to this person. But I cannot make any decisions because I don't have the data points to make a decision, right? How do you make a decision generally in your life? Example, which insurance to buy? Okay, you get these questions a lot. So okay. Which insurance to buy will depend upon lot of factors, lot of decisions that you take in the middle. So whenever you make a final call, okay, there are certain things that you will keep in your mind, okay, to make that decision. Those pointers that you keep in your mind before taking a decision are called data points. Okay, so more number of data points, higher it will take time to resolve. Okay, and but it can make a more advanced and wise decision, right? Similarly, application layer, since it has a lot of data points, it can actually read the packet. It can identify, okay, this path, send it to this person, this path, send it to this person, okay, this is the header, send it to this person, this is the domain, send it to this person. I can make a lot of decisions here. In network layer, all I get is the port on which the request is coming. That's all. Okay, so this works on TCP and UDP packets, like that part. So this works on basically TCP. Okay, TCP, UDP, TLS. kind of places where it works, this network load balancer. Okay. So now let's quickly create a machine which has small application called Nginx running in it. Okay. I'll try and log in into this server. Now I am in the system. I'll see if Nginx is running fine. Okay. Now let me try and hit this. I'm getting an application. Now this is directly hitting the server. Now what if the server goes down? My application goes down, right? So in this case, I'll go ahead and attach a load balancer. Like I'll attach this particular application to a load balance. I'll create an application load balancer today. Let's see how it works. It needs to be mapped to whichever subnet your machines lie in. This is a simple, okay, default one, it's fine. Create a target group. I'm creating a simple target group, as in what all targets should be there. Again, DevOps course TG. This is the protocol HTTP, because I'm creating a application load balancer which works on HTTP. So I'm creating HTTP health checks. Okay, next I'll attach my application. Create a target group. There is only one target. There is only one target. None healthy. So it is trying to see whether it is coming up or not. Okay, in some time. By the time I'll attach that TG here, do I want to enable WAF or not? I'll enable a simple WAF. This is basically important things that this gives. Okay, these load balancers give. They give you WAF functionalities and others. If you want to do it on your own, it is going to be either TDS or it's going to be difficult on something that sometimes is not given by the by reverse proxies directly. We'll just wait for it to provision. WAF is taking time. It is always good to have, okay, for all the load balancers that you create in any organization, in any cloud, anywhere. Okay, anything that is taking requests, it's better to be able to have WAF functionalities and other things to avoid any attacks. Let it come. Let it become provision. If you'll see here, you'll get two options: listeners, network, security, and others. So in terms of listener, you see there is only one rule that we have. Okay, so all the requests without any condition is routed to this one. I can add more advanced rules too. Let's first see if this works, then I'll add more rules to help you understand how these rules look like. So I'll just wait for the load balancer to come up successfully or to be in provision state. It might take some more time. Active. It is showing the same page which this was showing. And there is nothing hosted here. It is actually just taking the request and routing it to this Nginx. Okay. Now let me prove you this. I'm on that system. I'll make a change in this particular page. I'll have to use sudo to make a change here. Any change I make here should be reflected here too. First, number one. Welcome to DevOps Code. Acha. It's coming here in this. Let me just change this one also, heading also. You see, title I have changed before, so title is already changed. Let me see if this is also changed. Now this will also be automatically changed. This is also changed. Why? Because it is actually reaching from, it is actually fetching all the requests from the server. It doesn't have anything. Okay. Now in this application load balancer, basically we can add more rules. We can add more conditions to it. So these are all the rules that we have. I can add a rule saying that when I do slash test, it will show you Nginx uh, this. Okay. I can Okay. Now what I'm trying to say here is I'm trying to add a rule saying that if there is any path which says slash html, okay, confirm, forward this to this one, priority 100. I'll also add one more rule. Okay. Now if I do slash test html, it should show me that page. Okay. When I write slash test, it will not give anything. But when I write slash test here, it will give me anything. It will give me something. Why? Because this particular request is actually sent to me by load balancer and it's not reaching the target group. If you see here, I have three rules. One rule says slash test.html will go to this target group. Okay. Slash test is a static response which says 200 messages successfully reached. While default option, if none of them is actually available, then it will send the request to target group as it is already mentioned here. Okay, try it out, guys. Okay, I will cover network load balancers tomorrow, and then we'll start with uh, route 53s. Okay, but if there is any other doubts that you have, please feel free to ask me right away.